Alright, in this video I'm going to look at two examples of factoring polynomials by grouping. And usually we factor polynomials by grouping when we have four terms, and we'll end up using the greatest common factor method within factoring by grouping. So kind of the way factoring by grouping works is you're going to actually group the first two terms, and then you're going to think about grouping the second two terms. Now, one thing to note here is this kind of makes it look like it's multiplication, but it's actually in fact not multiplication. So sometimes it might be best to actually draw the parentheses more on the inside because you don't want to get it confused with it being multiplication. So on a problem like this, you're first going to group the first two, group the last two, and then you're going to look for the greatest common factor. So for instance, if I look at these first two terms, what is the biggest thing, the greatest thing that I can divide out of both terms? Well, I can divide z squared out of both terms. If I divide z to the third by z to the second, anytime you divide like bases, you're really just subtracting the exponents. Well, 3 minus 2 is going to give me z to the first, or just z. And then if I take 5z to the second divided by z to the second, I'm going to be left with just 5. I'm then going to do the same thing to the second grouping. So notice that I have 4z minus 20, but I also have this negative kind of hanging out in front. So I'm going to want to take out negative 4 as the greatest common factor between the two. Notice that 4 divides from 4, and 4 also divides from 20. Once again, I divide the negative 4 from both. Well, if I take negative 4z divided by negative 4, I'm going to be left with just z. And then if I take negative 20 divided by negative 4, I'm going to be left with positive 5. Now, just as kind of a side note, anytime we do factoring polynomials by grouping, we want to make sure that most book problems you're going to end with these two parentheses being exactly the same, so that we can actually take out another greatest common factor between these two terms. So notice that we have two terms here separated by this subtraction sign. We got this term on the left and this term on the right, and right now their greatest common factor is actually the entire parentheses z plus 5. Both terms have a z plus 5, so we can actually factor out the z plus 5, and then that will leave us with z squared minus 4 remaining. Okay, so factoring by grouping has been completed. Now, some problems will ask you to factor completely. And what factoring completely means is that you have to keep factoring until there's nothing else you can factor. So for instance, if I look at this first term, or this first grouping, z plus 5, there's no more factoring that I can do to this parentheses, so I'm done with it. However, if I look at z squared minus 4, from just years of practice and recognizing these different problems, I notice that I have a squared term here minus a squared term there. So this is the difference of squares. Now, there is a shortcut method for factoring the difference of squares, but if you don't remember that, you can always rewrite this with a 0 term in the middle. So I can rewrite this as z squared plus 0z minus 4. And now I have a trinomial that I can factor. So I'll have z plus 5, and then I can factor the z squared plus 0z minus 4. So what times what will give me z squared? Well, in this case, it's going to be z times z. And then I want two numbers that multiply to negative 4 and add to 0. Well, that's going to be a positive 2 and a negative 2. And then once again, to factor completely means I can't go any further. And if I check each of these parentheses, there's nothing else I can factor out of them, so this will be my solution.